Hello good day viewers. In this tutorial we are going to integrate the function 1 divided by x squared multiplied by the square root of x squared plus 1 with respect to x. Alright, let's get started. Before we start, I would like to simplify this. Let me take it aside. We have x squared times the square root of x squared plus 1. This is the same thing as x squared multiplied by the square root of I can write it as x squared in the bracket of x squared divided by x squared plus 1 divided by x squared. Right, I have just factored out x squared from these two times. Right, and the square root of x squared is x. So this becomes x squared multiplied by x as it comes out times the square root of x squared divided by x squared is 1 plus 1 divided by x squared. And x squared times x is x to the power of 3. So this is x to the power of 3 times the square root of 1 plus, I can even write this one as x to the negative 2 according to one of the laws of indices. All right, now let us back substitute. The whole of this is the same thing as this denominator. Let us take it back. So our integration of the function 1 divided by x to the power of 3 times the square root of 1 plus x to the negative 2. This is what we have with respect to x. And from here, we can simply take this x to the power of 3 to the top, and it is going to become x to the power of negative 3 according to one of the laws of indices. So this is the same thing as the integral of x to the power of negative 3 as you take it to the top, divided by the square root of 1 plus x to the negative 2 with respect to x. Now we are free to carry out substitution. I would like to let u be equal to 1 plus x to the negative 2. Now we're going to differentiate both sides. To the left, the u. To the right, the derivative of 1 is 0. And the derivative of this, you know, the power of negative 2 will drop down to multiply x. And you're going to subtract 1 from the exponent. It becomes negative 3 dx. Now let us back substitute. From our original function to the top, we have x to the negative 3 dx. But here we have negative 2 x to the negative 3 dx. The only difference is that negative 2. Hence, we can compensate, right? We can multiply this by negative 2 and divide by negative what? Negative 1 over 2. The moment you multiply this together, you're going to have 1. So it's a kind of compensation. All right, from here we can back substitute. The whole of this is nothing but du, right? So to the top we have only du. This is equal to the integral of du to the top. To the bottom we have the square root of, remember that we have let the whole of this to be equal to u. So we have square root of u. But don't forget this negative 1 over 2 outside. We have negative 1 over 2. All right. This is the same thing as negative 1 over 2 times the integral of, you know, we can write this one as u to the power of 1 over 2 according to one of the laws of indices. And you can simply take it to the top again so that the exponent becomes negative. This is equal to 1 over 2 negative, the integral of u to the negative 1 over 2 du. Now we are free to integrate u with respect to u. This is equal to negative 1 over 2 times u to the power of negative 1 over 2. You know, you're going to add 1 to the exponent. 1 divided by negative 1 over 2 plus 1 as well. Then plus the constant of integration. Now let us simplify. If you add this, you're going to have ordinary 1 over 2. So this is negative 1 over 2 multiplied by u to the power of 1 over 2 divided by 1 over 2 plus c. And from here we can cancel this 1 over 2 with this 1 over 2 once you multiply, right? Because 1 is to the bottom and 1 is to the top. So we only have negative u to the power of 1 over 2 plus the constant of integration. And this is equal to negative the square root of u plus c. And lastly, we bring back our u. Remember, we have let u to be equal to 1 plus x to the negative 2. So finally, we have negative the square root of 1 plus x to the negative 2, which we can write as what? 1 over x squared. They're all the same. Then plus the constant of integration. And hence, this is the result. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.